Hello everyone. So it's Thursday and it is I'm losing track of my days. It's 4th February now. And we're coming towards the end of our week of area and perimeter. I'm going to be moving our learning forward a little bit more. But first things first, for starter, it's changed a little bit today. So instead of a word of problems where I want you to do some fluent in 5, so I want some calculation. So you have 5 problems here. I'd just like you to solve them. Some of them you can do mentally. So think which ones you can do mentally. And some of them you can do with a written method because mentally it might be too tricky. Doesn't matter which, but I want you to just think about which method you'd use for which. So pause it, give them a go, then we'll go through the answers. Awesome. Right, let's go through some answers here. So the first one I would have done written because there was lots of exchanging. So 125,590 was your answer. Second one, we could have just added by whole numbers, 1 add 2 to make 3, and then added, the denominator would stay the same because we're adding fractions, and then 1 add 1 is 2, so 3 2/3. The third one, 3.21 times 3. You could have done it written if you wanted, but really just times each of the numbers by 3, so 3 times 3 is 9, 3 times 2 is 6, 3 times 1 is 3, then 9.63. Second one, again, lots of exchanging, so I would have done it written to get an answer of 644,657. And then the last one, 3 squared, is 3 times 3, which is 9. So hopefully we were okay with those and have warmed up mathematically now. So today we're looking to find the area of a parallelogram. So the keywords, star words, parallel, quadrilateral, rectangle is going to be vitally important for us today. Base and perpendicular. So remember, parallel means running side by side. Perpendicular means running at a 90-degree opposite angle. So here is a parallelogram, 2 sets of parallel sides. Now, the formula we use to find the area of a parallelogram is based on creating a rectangle by moving a triangular portion. I've created my own portion of that parallelogram, and I'm going to move it to make a rectangle. So here is a parallelogram, and I've drawn over the lines to show you I've created a red triangle, which I'm going to move. This line I've created, because this isn't a line that exists, it's not one of the lines of a parallelogram, this one is called the perpendicular height. Okay, because this is the parallel line, the perpendicular height goes at a 90-degree angle up to measure the height. It's the direct height, because this height's a bit slanted. Now I'm going to move that triangle, and hopefully you'll be able to see. I'm going to move that triangle across here to the other side. That has then allowed me to create a rectangle. I have left the perpendicular height because that creates a side of my rectangle. Okay, so now I've got a rectangle. We know to find the area of a rectangle, it's base times height. That's it. So that is just to prove that I've not got rid of anything. I've just moved some of the shape, so I can still use the formula base times height for a parallelogram. It might not look like a rectangle exactly, but we can still use base times height exactly the same to find area. And you were all wonderful at that. So I think you'll be fine today. So here is a parallelogram. I've got a perpendicular height shown here of 6 centimeters, and I've got a base of 11 centimeters. Base times height equals area. 6 times 11 equals 66 centimeters squared. Because we're working area, we put squared after our answer. That's it. Base times height. As long as you've got a perpendicular height, and you've not got a side length here, which wouldn't be useful. As long as it looks like a height, the full height of a shape, that's it. You can find your area. This one, 7 times 4.5, because base is 7, perpendicular height is 4.5. 4.5 times 7 is 31.5. So our area is 31.5 centimeters squared. Exactly the same formula as rectangles, just as easy. So what I would like you to have a go at now is using the base times height formulas to work out the area of these parallelograms. Some of them you will have to do the times in decimals we've just done, but I've shown you exactly how to do that. I'm going to scroll down so you can see all the measurements on the screen without that annoying ink mark. So there are your 4 shapes in your home learning books. Give it a pause and find the areas of those parallelograms, please. Off you go. Fantastic. Right, let's have a look at some answers. So, area of this one, 9 times 8. was 72 centimeters squared. This one here, 6 times 12, was again 72 centimeters squared. This one here, 22 centimeters squared. And then your final one was 13.2 centimeters squared. Hopefully we did okay on those. These skills are going to stand you in good stead because this is what your mathematics activity is going to be about. So can you log on to mathematics and complete your activity? The area of a parallelogram, remembering it's just the same formula as the rectangle and square formula to find the area. Don't be confused because it looks like a shape we don't see a lot. Once you've done that, back you come, and we'll go through the next part of the session. So pause it and go and do your mathematics, please. Right, so hopefully we're back. And if you found that mathematics a bit tricky, I'd suggest you go back and look over the video again. Just watch the area of a parallelogram and how we find it. Right, so here are two problems. In your home learning book, I want you to please explain and solve these ones. So the first one is here. Dexter thinks the area of a parallelogram is 84 centimeters squared. What mistake has he made? What's the correct area? This one takes a bit more in-depth thinking, but it's gettable. So Dora and Eva are creating a mosaic. They are filling in a sheet of paper this size. So here's your sheet of paper. Dora is using tiles that are rectangular. Eva's tiles are parallelograms. Dora thinks, so Dora doing rectangles, thinks she'll use fewer tiles than Eva and her parallelograms because her tiles are bigger. So do you look bigger? Do you agree? Explain your answer. So think about the formula and it'll help you with your explanation. So pause it, give these two a go. The explanations are key, so please try and write an explanation in your home learning book and then we'll go through answers. Off you go. Right, so we're back and we'll go through the first one. So Dexter has multiplied the 14 by the 6, which has given him 84. And this we know is not the perpendicular height. Okay, we know that that's not what we times by. The perpendicular height was given to you here as 4 centimeters. So we actually, what am I doing now? I put 6 again. See, I've been confused by it. There we go. So he's multiplied 14 by 6 when he should have multiplied the perpendicular height 4 centimeters instead. So 14 times 4 is 56. Okay, so 14 times 4, the actual area is 56 centimeters squared. The next one. So Dora is wrong, first thing, because they'll use the same number of tiles because they're using exactly the same formula and exactly the same measurements. Dora, the area of her rectangles will be 3 times 5, 15. The area of the parallelograms will also be 3 times 5, which will be 15 centimeters squared. They're the same size because remember we use the same formula. So to just check how many we'll use, make sure they use the same amount. The area of a paper is 19 times 15, which is 285 centimeters squared. Dora and Eva's tile area is 15 centimeters squared. So let's see how many we'll use. So we divide the 285, the whole area of the paper, by the area of the tiles, and it gives us 19. So they will each use 19 tiles. They use the same. So Dora was wrong. Silly Dora. Right, finish. On to TT Rockstars, please. You're doing well this week. So make sure you get yourselves on there and get that fluency practice going, please. And we'll be back for our final lesson of the week tomorrow. Bye-bye now.